Hello and welcome everyone to this PASS Marathon Analytics. We are excited you could join us today for Shabnam Watson's session, Aggregations in Power BI. This PASS Marathon features back-to-back live webinars delivered by expert speakers from the PASS community. The sessions will be recorded and posted online after the event. You will receive an email letting you know when the recordings are available. My name is Michal Poręba and I will be moderating this session. I have a few introductory slides before I hand over the reins to Shabnam. If you require technical assistance, please type your request into the question pane located on the right side of your screen and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I'll read your questions aloud to Shabnam. You are able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. Please note that there will be a short evaluation at the end of the session, which will pop up after the session ends in your web browser. Your feedback is really important to us for the future events, so please take a moment to complete this. So, let's keep learning all year long. Visit pass.org and check out all the free educational resources available to PASS members. Connect, share, and learn. This PASS Marathon session is presented by Shabnam Watson. Shabnam is a business intelligence consultant with 17 years of experience developing data warehouse and BI solutions. Her work focus within the Microsoft BI stack has been on analysis services and Power BI. She is an active member of PASS community, and she has spoken at PASS Summit, PASS SQL Saturdays, PASS Women Technology Virtual Group, and other local user groups. This year, she's one of the official bloggers of PASS Summit 2019. You can follow her on Twitter and her blog for summit-related news. So, without further ado, here is Shabnam with Aggregations in Power BI.
Thank you, Michal. Hello, everyone. This is Shabnam Watson. Thank you for joining us today. I'm going to be talking about aggregations in Power BI. And we are going to cover what are aggregations, why they're useful, and we're going to talk about different storage modes in Power BI and how they can set up the stage for creating aggregations in Power BI. We're going to talk about how to configure them. And recently, aggregations work with row-level security in Power BI. We're going to look at that. And while I'm going to be doing demos, I'm going to show you how you can actually monitor to see that the aggregations are being used. So I believe there was, we were supposed to have a poll where I could figure out.
Yes, it is available now.
Okay, so there is a poll available for you that would give me a little bit of better information about who you are and your background to see how much you've used Power BI as a modeling tool before. That will help me present this session better. So if you take a moment and give us that information, that would be great. So while you're doing that, let's talk about aggregations. So aggregations are, in general, they're summary tables. They are a way to help performance of queries that work off of large data sets. They're not specific to Power BI or the SQL Server world. If you work with other database systems, they've always been there. So you work with a large data set that has billions of rows in it, and then you have some executive dashboards or reports that need to summarize that data. At the time when the executive opens the report, instead of the report going to low-level data, going through billions of rows, you have some kind of summary table or structure available for that high-level report to hit. So that is called an aggregation, and exists in different ways and forms in different systems. Now, as of July of 2019, aggregations are generally available in Power BI Desktop, and they're supported in Power BI Desktop and Service in shared and premium capacity, along with role-level security. The benefit of them, obviously, is that they will improve the query performance, especially on analytical dashboards. So when you look at a Power BI dashboard, a good Power BI dashboard should not have more than 10 visuals, and they're very high level graphics or charts, right? If we have even hundreds or thousands of rows, as a human, we cannot process that. So the visuals on a Power BI report, they're always at the high level. And it's great if they can be answered from a summary table. So even though the big benefit for using aggregation comes when you're using a trailing row, quarter petabyte data set, you can use it for any case when there is a reason for you that it's expensive for you to cache that information, whether it's time it takes to load it into memory, whether it's CPU or resources. So it even applies with smaller data sets. Now, if you haven't seen the trailing row demo, I have a link in here. It was done by Christian Wade, and you can go and see how a trailing row data set, a quarter petabyte, that's based off of an Azure Bricks cluster, is being brought into Power BI, and it's literally just drag and drop, and you can see sub-second answers from that large of a data set. And the reason that works is because aggregations are being used in Power BI Desktop. Okay, so we're going to look at how to set up Power BI aggregations today. All right, so first of all, Power BI, yes.
Sorry to interrupt you. We just sent you the results of the poll.
Okay, all right, great. So let me see. So we have about 17%. They've never used Power BI Desktop as a modeling tool. 71% have basic knowledge, and we have 20% experience. So that is great because coming into this session, we're assuming that you have used Power BI Desktop to some degree to create some models. So it's great. It seems like the majority of people have at least used it at the basic level. Okay, thank you so much. All right, so Power BI Desktop, before we get into aggregations, I have to set this clear because this is a point of confusion for some people. Power BI Desktop is both a front-end reporting tool and a modeling tool. So you can use Power BI Desktop to live connect to a Power BI dataset or to an analysis services database and create your report, right? At that point, the model's already created somewhere else for you. You can also use Power BI Desktop to create your own semantic model with or without data. We're going to talk about that. Now, once you create that model, you can enhance it with aggregations. This is where we're going to focus today, right? So once you create your model, other people connect to it. If there are aggregations in it, good for them. Their query is going to run faster. But the end user has no awareness of the aggregations being in place, okay? So at a high level, this is what a Power BI model does. You connect to a data source, for example, a SQL Server data source. You bring in the definition of your tables at the least, and you define relationships so that when someone connects to your model, the relationships are predefined. If they're going from internet sales to product, they don't need to know that they have to make the join on the product key, for example, right? And depending on the storage mode of the model may or may not connect the actual data. Once this is all done, all the front-end reports will connect to your model. Now, sometimes a Power BI desktop file contains the model and the reports in it as well. But a better design, especially when you're sharing, is that you have a model that's just a model, and then you publish it to Power BI service, and then other people connect to it and use it just like a database, just like you would be connecting to an analysis services database and build their reports, right? So back to the model, there is two ways that you can deal with data, right? One is called import. In import mode, a copy of your data from your source system gets to your model. So from your SQL Server database, for example, a copy of all of your tables comes into your Power BI desktop. It comes in your Power BI desktop file, right? In this case, Power BI is storing data in a Vertipack engine, which is a columnar, highly compressed memory engine, right? And any query that comes in is being answered from memory. It's super fast. It's great, right? The other end is called direct query mode, where when you connect to SQL Server, you say get data. Once you pick your table, it always asks you, it says, do you want direct query or do you want import? If you choose direct query, it means that all queries now are being answered by SQL Server. So Power BI is just working as a semantic layer. So it will help write those SQL queries so your user still is not writing the queries. It's just asking for information. So for them, it's still just drag and drop, but now the queries go back to SQL Server. And if this is a large data set, it's going to take longer. So if you put import and direct query side by side, they each have their pros and cons. Typically, you want to go with import because in memory is faster. However, there is a load time because you're copying data over, right? And now you also lose the near real-time requirements. So if you're working with a data set that needs to be up to date, almost near real time, then you have to go with direct query. That's the main use case for direct query. Or if you have a data set that is super large, trillion rows, it doesn't fit in memory, you have no choice, right? You have to leave it in direct query. The downside is, of course, now the performance is going to be slow. Now, the good news is Power BI Desktop allows you to pick and choose at the table level. So it used to be you had to pick direct query or import, but now you can have a composite model where you can define the storage mode of each table at the table level. So for example, you can say, I'm going to leave my larger fact table and one of my dimension table that updates frequently back in the SQL Server database. And I'm going to bring my dimension tables into memory. So now the slicers on my Power BI desktop are going to be refreshing very, very quickly, but it's okay for the rest of the queries to wait a little bit. Okay, now, let's see what happens with aggregation tables. So I'm going to bring in now an aggregation table. So let's say that we have a summary table or an aggregation table that has summarized data by date and product subcategory. So it's at a higher grain and it's smaller now. And I want to bring this query and leave this into memory. So this is great because now the aggregation table can sit into memory and the detail table can sit back into the backend database. And this is the basically this is a good design pattern for using aggregation tables. Now, the question is, we still have one more piece of this puzzle to explain. So the question is, what happens now if you ask for sales amount by sales territory? So both of them, of course, are in direct query, so it's going to be both answer from direct query. But what happens if you ask a question of sales amount and product, right? Sales amount and product. Now remember, the aggregation table here is at product subcategory, it's not at product. So sales and product still has to be answered from the main detail table. So the issue here is, at this point, this will end up with a join in Power BI because the detail table is in SQL, the product tables in Power BI Desktop. Power BI has to get the results from SQL Server, bring it into memory, do a join in memory. This join would have been a lot faster if the product table were in direct query. So it's almost as if we want it to be sometimes in direct query, sometimes in memory. And that brings us to the dual storage mode, which is exactly what we needed. So in dual storage mode, the tables are like transformers. They change storage mode. So on demand, they can decide whether they're going to be answering a query from their copy in memory or their first copy in SQL Server. So in this case, the sales territory and internet sales detail table are still in direct query. The rest of the dimension tables are now in dual. So this means that if a query comes, then it's asking for sales amount by date and sales territory. It can be answered from direct query, date tables acting as if it were in direct query. And if a query comes and it asks for sales amount by year, now this query can be answered from aggregation table that happens to be in memory. So date, because it's dual, can also act as if it's in memory, and everything's answered from memory in this case. Okay, so aggregation tables are just like any other table. As far as Power BI is concerned, it doesn't matter to Power BI Desktop whether you created this with a view in the backend database, whether it's a table, whether it's got indexes, whether you imported, you're leaving in backend SQL Server. It's the concept of the aggregation is separate from that. So of course, if it's in memory, it's faster. If it's in the backend system, it's more up to date. But regardless, from Power BI Desktop, it's just like any other table, and you're going to see that in a moment. Now, aggregation tables, once you mark an aggregation as a table as an aggregation, it will automatically become hidden now with the newer versions of Power BI Desktop, and it will no longer be accessible to end users. So end users won't be able to query it. You as an admin, you can still see it. All right, and you're going to see when I start setting up aggregations, I have to give it some basic, I have to give Power BI some metadata to tell it that if a query comes in asking for these attributes, instead of going to the detail table, go to the aggregation table, right? And that's done by the manage aggregations property of the aggregation table. And there is two ways that you do that. And as I'm going through that, I want you to pay attention. There's two ways to set up aggregations. One is based on relationships that are defined in the model. So for example, product from product table to product key in internet sales. And the other one is by group bys that I'm going to explain. Group bys are used for large data sets such as the Hadoop-based systems. Okay, so I'm going to switch to demo at this point. If there are one or two questions so far, I can answer them at this point. Otherwise, I'm just going to continue. So,
There was
Michal,
one question about the aggregation support on direct query modes. You had on the previous slide that there are some limitations. Do you want to expand on that, or?
Yes, so there is some limitation. If your aggregation at this point, your aggregation table and the detail table have to be from the same data source unless you're using the following following databases: the SQL Server, Azure SQL, or Azure SQL Data Warehouse source. So there's a little bit of limitation on that at the moment. Okay, so a little bit of background information. So I'm working off of the AdventureWorks sample database. I've created some views for my model, and the views are just simplifying the dimensions. So I am taking away all the extra columns that I don't need to just make it easier. I'm renaming, putting some spaces in there. So for example, if I run this query, this is my product table. I'm just picking a few columns out of it. So I have a few views. I have dim product, dim date, product category, product subcategory, and sales territory. And then on top of that, I have created two tables. So these are actual tables in my SQL Server database. I'm going to run the query that populated one of my tables. So the first table is by product key, by calendar year, and I have my quantity columns. And as you can see, this one, for example, from instead of 60,000 rows in the detail table, I'm down to 288 rows, right? And I have another table also prepared that this one is summarizing data at the calendar year level. And obviously this only has 5 rows, right? So in Power BI Desktop, I have brought in these tables. Now everything that you see right now is in direct query mode. And the way I know that it's in direct query mode is because not only the name I gave it, but also if I go here, and if I look down here, it tells me that the storage mode is direct query, and I can click and change, right? Okay, so I'm going to go back here. This is a very simple model. You can see it's a star schema with a little bit of snowflaking on this side. So the product, subcategory, and product category are chained up. And this is my aggregation table. And I have created a relationship here because the product key exists in the aggregation table. So I've been able to connect it. Calendar year is not connected to anything. And this other aggregation table is not connected to anywhere either. And that's because I cannot really connect calendar year to the date table. Date table is a different gray. So that's intentional. I want to show you something there. So right now, if I run a query, there is no aggregation, there's nothing defined at the moment. These are just tables. So I use a tool called DAX Studio. If you haven't used it, it's an excellent tool for learning DAX, for writing DAX, for performance tuning, SSAS Tabular, or Power BI models. Once you start DAX Studio, if you have your Power BI desktop open, if you do the drop down, you're going to see the Power BI desktop that's open, and you can connect to it, okay? So once it connects, you see the list of your tables. You can start writing DAX. It has IntelliSense. I'm going to open a query that I've saved from before. Okay. So once this opens, there's a button up here called Server Timings. And I'm going to click on that. What it does is it starts a trace against the Power BI desktop. So as it runs, it's going to be able to give me some information other than just the results, right? So I'm going to highlight this and hit run. Okay, if I go to the results, I see that I'm getting product key and sales amount for each product key, which is great. I'm going to skip over these 2 tabs, not related to today's topic. I'm going to go to server timings. When I go to server timings, it tells me some information about how long it took for the query to run, how much of it was in Formula Engine, how much was in Storage Engine. Right now, most of it is in Storage Engine because we're in direct query mode. Everything went to the SQL Server backend. And if I look at this event that it generated, it actually gives me the SQL that Power BI Desktop sent to SQL Server to answer the query. So you can see that it's going to fact internet sales and it's doing a join with DIM product. Both of them are in my SQL Server database, okay? So I want this query, instead of going to the detail table, to hit the aggregation table. How do I do that? I'm going to come back to the aggregation table and go to manage aggregations. Now notice this is everything still in direct query. So an aggregation table does not have to come into memory. It's still back there, but I'm going to guide all the queries to go hit the aggregation table instead of the detail table. There are a few properties here you can set. For now, we're going to skip product key and calendar year, and I'm just going to set sales amount. Sum of sales amount from internet sales, and I'm going to say sales amount. Now, the way I read these aggregations, that's easier for me, is that I read this from right to left. So I say, if a query comes in and is looking for sales amount, in the internet sales table, use the sum of sales amount from the aggregation table. So I read them from right to left, and it makes more sense to me. I'm going to do the same thing for counts. So I have a count on the unit price, and for unit price, I have intentionally set up both a count and a sum because I want to show you something there different than product, different than the sales amount, okay? So I have a sum, I have a count, I have another sum, and also I have a row count in that table defined. So I'm going to say count table rows and internet sales. So at this point, all I've done is I've defined just the values, right? I haven't said what to do with product key, or calendar key. I'm going to say apply all. And as soon as I do that, the aggregation table becomes hidden. See, now you cannot see it anymore. I'm going to go back here and I'm going to rerun the same query. Now this time it's going to do something different if I did everything correctly. So now you see there is an event generated and it says rewrite attempted. And it was a match because I was able to set up the properties correctly. Now if you look in here, it will tell you what the request was, right? And what the mapping was. So it's able to find the mapping. Now, why is it able to find this mapping? Because we didn't tell it to do anything with the product. The reason it's able to do this is because there is a relationship in the model. That arrow exists in the model. Okay, that's why it's able to figure that out, which is great. And now if I look at the SQL query, I'm going to see that it's going from the sales ag table to the product table instead of the actual detail level table. So once this is working, it's great. Now it's going to work for any other property of the product also, or product category. If you want to see how a fail works, if I run this now off of order quantity was not in my aggregation intentionally, and you're going to see it says it failed, and you can look at the details. It will tell you why it failed. Missing aggregation right here. Okay. So we know that it's going to work off of product name. It's going to work off of product category name. All of these are going to hit. And I'm going to go back to unit price. Let me run it for unit price. It's going to have a match, which is great. And it's going to have a match for the count of unit price because we added that. So the question is, do you think it's going to work for the average at this point? Because I didn't define an average in there. But is it going to be able, do you think it's going to be smart enough to say average is a sum divided by a count or not? Well, let's see. And it looks like it did a match, which is great. And now if you look at the details on the data request, you're going to see that it did exactly that. You can see that it found the count, and it also had the sum, and it did the division, right? So the aggregations that you define, they will help a lot more queries than what you might think. A lot more complex calculations are able to be broken down into their pieces. All right, so what about the group by then? We haven't seen the use of the group by. Now, if I run a query by calendar year, I expect the aggregation to be used, right? Because the aggregation was at the calendar year, but haven't done anything with it yet. So now it's going to fail, doesn't know what to do with it. How do I tell it that that calendar year, this calendar year, is the same calendar year here? Because I cannot connect them. The way I do that is by doing this. I go back to the aggregation, and this time I'm going to choose group by. And I'm going to tell it that if you get a query that's asking for the date, calendar year of the date table, use the calendar year of the aggregation table. Now that I do this, if I go back to my DAX query and I run it, it's able to use the aggregation because now it has the mapping. So there is two ways to set up the properties. One is by using the relationships, and the other one is by setting the group by. The group by's use case is mainly for large data sets when or cases where you don't have relationships for whatever reason. It's a different grain or just the way the data is, you can connect them. Okay, now let me go back to here. So we already did the calendar year. Now I have another question. If I want to get the distinct count of products, so I'm going to show you another use case of the group by. This query right now is showing distinct products sold by color, right? And it's not able to find this information in the aggregation because our aggregation only had sum and count and count rows. It didn't have distinct count, right? But there is a way that we can help it a little bit. So if I go back to the aggregation and go back to the product key, now remember, I don't need to do this so that the product, so that it's able to answer queries by product. But if I set it up, it's going to do something. If I say, whenever you're trying to count the product key, distinct count in internet sales, you can use the product key from the aggregation, because remember, distinct count is the same thing as a group by. If you ever write SQL queries, you know distinct versus group by, they're the same thing. So now if I do this, and I go back here, and I run this, and I've done this correctly, now it found the match. So this is the second use case of a group by. All right, so we've seen the group by use case. Now I want to show you what happens if you have more than one aggregation table. So right now, if I run a query that's by calendar year, it's going to go to sales ag 1 because that's the only aggregation I have, right? I'm going to go and enable the second aggregation. And for this one, I'm going to again define the group by calendar year. And for the sales amount, I'm going to say sum internet sales amount, and click apply. By the way, if you make a mistake and you choose unit price, it's not going to return unit price instead of sales amount in your queries. It will just fail to use the aggregation. I actually found that by accident, that the aggregation wasn't being used, but thankfully it's smart enough to not use it. Okay, so I'm going to say apply all. Now this one also becomes invisible. Now if I go back here to DAX Studio and I'm going to run this, now let's see which one it picks. It's picking the other aggregation, which makes sense because it's smaller, right? But if for whatever reason you wanted to still go back here, you can set this property called precedence. So you can set this to a higher number, and that means it will be considered first. If the query can be answered from this, then it's going to go to this aggregation, otherwise it's going to hit the other one. So now if I go back to same query and I run it, I'm kind of forcing it to go use that aggregation. It's going to that one. Okay, so that's the precedence. Now, so far, everything's happening in direct query. So even though everything's still in direct query, but the aggregation tables are smaller tables. So if this were a real large database, you would have seen a difference. And even on my machine, being the difference between 60-row table and 100,000 row table sometimes is visible with the amount of memory that I have on my machine with SQL Server running. So now I want to bring this table into memory, and that's great because now we can go to the properties pane. So once I select a table, I see the properties. If I go to advanced, I see that it's in direct query. And now I can change it to import. Now, the moment I do that, it's going to give me a bunch of messages to make sure that's actually what I want to do. So first of all, it says, if you change the storage mode from direct query to import, it's a one-way trip. You cannot go back. So make sure you save your Power BI desktop before you do this if you're not unsure of this, because you won't be able to change it back. The second thing it's telling me is that, well, this is going to take a while because it's going to refresh. So depending on the amount of data that you have in the background, it's going to take a while, which is fine. And the third thing it's warning me about is something about weak relationships. and it wants to change the storage mode of the other tables related to the aggregation table to dual. Now, a weak relationship is defined when you got two tables that one is in direct query, the other one is in import. So they're in opposite storage mode. If both are in direct query, it's considered a strong relationship, and aggregation will be considered to answer the query. Both in import, it will be considered. If it's one import or direct query and the other is dual, where it can flip back and forth, that's still a strong relationship. But if you got one import, one direct query, the ag will not be used. So if I don't set these tables to dual, this ag will not be useful. And of course, you don't have to do it here. You can do it manually, right? But I'm going to let it do that. So I'm going to click OK. And so it's bringing a copy of all those tables into memory right now. Okay, give it a minute. Okay, so now if I click here, you see that this is dual, this is dual, this is dual. This is still in direct query, and this one is in import at the moment. Okay, now if I go back here to my report, by the way, you can see that the storage mode is changed to mixed. All right, now I'm going to go back to DAX Studio, and I'm going to run a query on product category just to get a list of product categories. And you see that this is a scan. This is no longer SQL. It's being answered from memory, and this is not SQL, right? But if I ask for sales territory, this one's being answered from the SQL source. All right, so now let's run a query that returns internet sales amount by the color. Okay, so this time it tried to answer from the aggregation, which it's successful, and now it's able to answer everything from memory. So previously, if you looked here, whenever we had the ag hit, it was still going back to the backend, but now it's able to answer this entirely from memory. If I ask for order quantity by the product color, that's not in the aggregation table. Now, if you look at it, it's going to rewrite fails, and now it's going back to the SQL Server copy of the product table. It's going back to the DIM product. So depending on the query that's coming, the nature of the product table changes. Okay, so I have a couple of other things to show you. One thing that I want to show you is that the role level security. So it used to be that when you started aggregations, you were not able to enable role level security anymore. But now you can. So this option was disabled before, but now you can. So you can go to manage roles and create a role. So I'm going to create a role that's called color. And the way it works is if you create a role level security, it has to affect there's a couple of ways that it can work. One of them is that it has to affect both the aggregation table and the detail table. It doesn't make sense to secure one but not the other, right? So the most common scenario is you have a rule that's securing both of them, because now you have a mixed mode. Whether someone hits the memory or the backend database, you want to have consistent results. So if I can go here and if I define a filter on the color, and if I say color equals red, that's great. This role level security is gonna affect both internet sales and this ag table, because both of them have a relationship. So the filters flow from the one side to the many side, and the relationship is gonna help. So this is great. And if I create a role called territory, now, territory, I want to put a criteria on territory. Now, if I say territory where country equals United States, if I create this role, what happens is if anybody asks questions about internet sales, even by product, even though the information is available to this in this aggregation table, this aggregation table is going to get bypassed, because in the cases when they go to the back end, they're going to only be limited to United States, but the aggregation table is loaded into memory with everything, and it cannot filter only on sales territory because there's no relationship. So the engine is smart enough not to use the aggregation, it will bypass it. And the last scenario that doesn't make sense, and Power BI Desktop actually stops you, is that if you try to set a filter on the aggregation table itself that you haven't set up on the detail table. So if I just go and say calendar year equals 2016, and if I try to save this, it's going to stop me. It's just going to say, this is nonsense. This cannot happen. So that's the quick summary of the role level security. And again, you can, from DAX Studio, when you're connecting, you can connect and test with the role. When you connect, it will give you an option for advanced, and you can, in the role here, you can put the actual name of the role, the security role, and you can test all of that. And when you look at the queries, you're going to see that that role level security criteria is actually being pushed down to the back end SQL queries for the queries that go back there. And the one more thing I want to show you from here before I go back to my last couple of slides is that if you pay attention down here, something really neat about DAX Studio. It shows you something down here is localhost and a port number. And this is actually the analysis services tabular instance that Power BI Desktop started when I opened Power BI Desktop. So I can connect to it from any of the tools that you can use to connect to Analysis Services Tabular. So here, for example, I can start a trace, and I can go to that port number. Now the port number changes every time you open a Power BI Desktop, so pay attention to that number. So I'm going to go to 724, connect, and now I can pick my events. So usually you can have a template saved. So I'm going to do query begin, query end. And there's this event here called aggregate table rewrite query. This will give you the same information that DAX Studio was capturing and showing to you. So if long-term you're capturing these events, you can use the query profiler, or you can use extended events instead of DAX Studio. But DAX Studio gives you a quick way of spot checks, and also getting that port number is very easy from DAX Studio. So if I run this now, it's going to give me information about all of these queries. So any query that I click, if I go back here, it's going to show me what was used and what wasn't used. So it's the similar kind of information. Again, match found, what was the reason it couldn't match, okay? All right, so let's go back real quick because we want to have a few minutes for questions left. All right, so we talked about the group by columns, that you can use them for scenarios when you don't have any relationships. You can use them when you're trying to help the distinct count calculations. We talked about the aggregations only hit when there are strong relationships in place where both sides have to be the same. So for example, you have to be direct query works, direct query dual works, import or import dual works, but direct query and in-memory doesn't work. So if the aggregations aren't being hit, you can look at that. You have to always monitor aggregation usage to make sure they're actually being used. Remember, there's a cost to the aggregations regardless of where they're created. So even if they're your backend SQL, even if they're a table in your SQL server, you're still spending time populating, keeping up to date on all that. It's important to know if it's actually being used. If you have a background in SSAS multidimensional, you might have seen that you would have ended up creating maybe a few gigabytes of aggregation files, but they would have never been used in some cases. So it's very important to capture it one way or another from one tool or another tool. Okay, and we saw that the role level security is great. That now works. You just have to pay attention to the rules. And we looked at the precedence. Now the precedence is good when you have multiple layers of aggregations, and basically you can implement a hybrid architecture where you have a balance. So you put your big data, IoT data back into the IoT system, and maybe you have now a data warehouse that has some, it's going to answer some of your BI queries, right? You have some tables in there. There's still several 100 million rows. And then at the third level, you have Power BI cache, where it's going to answer those executive queries super fast. And regardless of how you create an aggregation table, you always have a maintenance that goes with it. So it's the responsibility of the report designer or architect to make sure that what's in memory is actually in sync with what's back in the backend database. Power BI is not going to stop. It's not going to detect that the in-memory cache is out of sync with what's in the backend database and try to remedy that or redirect queries. Okay. Now, finally, when not to use aggregations, obviously they're not used for they're not useful for all queries. If you have row level calculations happening, they're not going to be useful for them. For those cases, you can create a calculate column, and in some cases, you can have a calculate column and then use an aggregation on top of that. And just as a summary, their aggregations are available to use regardless of your data size. They're an excellent tool for optimizing performance queries of the high-level Power BI reports. Remember that at this time, they only work on direct query tables. You cannot enable them on another aggregation table. You cannot create them on top of an import table. I heard that that's coming on a future release where you can create aggregations on top of the imported tables. And finally, the last note that I have for you is that do not use aggregations to go around having a good data model. Good data modeling is still the best practice for good performance. However, there are a certain amount of data sizes that when you hit, aggregations are going to be a tremendous help. I have some references here. There's a link to that original petabyte aggregation demo. There's an updated version of it from this July that you can watch. The original one from past Summit 2017 is there. These are very interesting demos to watch. And then you can follow the Power BI blog for information about aggregation as they progress. So with that, if there are any questions, let me know.
Yes, thank you, Shabnam. We've got a few questions. First of all, there's a question, how do you go to storage mode screen? Can you show that again, please?
Of course. Okay, so this has also changed a little bit. If you had a lot of the online help that you look at, if they're with the previous feel and look of the Power BI desktop where it had the darker colors, it was in a different place. I think you were able to get it from here, but now everything's back in the model tab. And that took me a while to find it when I first started looking for it. So you go to here, you have to pick a table, and then you look under advanced. And here it is, direct query. So this section used to be under a different tab before, and a lot of some of the online help or the blogs that you read might still point you to there, where you can actually find it under, like from here, you would pick a table and you go to properties, but it's no longer there if you have the most up-to-date version.
Okay, with the next one. There's a question about the aggregate tables and the fields. Do they need to have the same fields as the detail table?
They don't have to have the same name. They need to have the same data type, and you don't have to have all of the fields. So for example, you can have, if you look at this table here, if you look at this aggregation table here, it only has sales amount and calendar year, whereas my detail table here only has sales amount. So not necessarily, but it makes sense for you when you're creating an aggregation to include at least all of the quantity columns that are in the detail table, because you want to point all the queries to the aggregation table. And when you're creating this table in SQL Server, the cost of adding those extra columns is minimal.
Okay, and now we've got a long question, which I think I'll just read as it is. Hi, a question I've had for a while. We are a healthcare system, and some of our fact and dimension tables are hundreds of columns. I have thought about having aggregate tables at the exact same grain as the original table, but with only the most common columns, 5 to 10 maybe. Queries accessing other columns would go back to SQL. Have you tried this before? All aggregation talks speak to reduce rows, but summarizing, in my case, I'm trying to reduce columns.
I see. That's actually a good question. I have not tried that personally, but if you set okay, so if you set the aggregation properties, obviously it's going to hit that smaller table. Now, if your backend table though, if it's in SQL Server and if it is, I don't know if it's optimized by, depends what the storage of your backend SQL Server table is. So if it's a row based, then the table with fewer columns in Power BI Desktop, obviously, even if it's direct query, is going to work faster, right? Because it's going to have fewer columns. But if your SQL Server table is in cluster column store index structure, and you have queries, the Power BI Desktop queries only target certain columns, I'm not sure how much that's going to buy you in terms of a performance improvement. I hope that answers some of your question.
Okay, thank you. Back to basics. How to create an aggregation table?
Okay, so let me go back and I'll show you. I have, for example, I'm working off of this Adventure Works database, and I have my fact internet sales, right? This is just a view on top of my table. So in this case, I've just run a simple query and I've populated a table with it. So it's an actual table in my SQL Server database. It can be a view. It does not have to be a table. It can be a view. It can be a table. If it's a table, it has to be part of your ETL process or part of your data flow. So you got your large table. When the large table is populated, after that, or as part of that, you will update your smaller table and use that table. Or you can entirely create it in Power BI Desktop. You can use an M expression and completely create a table over there. So you can create a summary off of the other tables in your model.
So it doesn't matter how it gets to the model, as long as it's there,
It
you
does
can configure it as
exactly,
aggregation.
exactly.
So in a sense, the aggregation doesn't have to be correct. It's not like a view or a clustered view.
So that's actually a good question. So you could potentially, I haven't actually tried this. So are you saying that you could create a table and like instead of providing actual sales amount, what if I provided just 1 for everything or 0 for everything? Yes, Power BI is not going to know that. It's going to go and fetch
Yeah.
them. Yes. So again, it's like it becomes like any table as part of your entire data flow, and you are responsible for its maintenance. If you set it up correctly, it's going to have a lot of benefits in terms of query performance for your end users.
Okay, so there is one question I think I can answer about the transcript. Perhaps we will have it with a recording. There is a new feature with GoToMeeting which hasn't been fully explored yet. We'll have a look at that. Next question for you, Shabnam. Would the role-based security get applied to the aggregated tables?
Yes, it does. So if you set up the role-based security on an attribute that's directly related to the aggregation table, it does get applied.
But of course, it cannot filter out things from the aggregation itself.
Right. No, it doesn't take things out. It's just that if you have a user that falls under that role, then yes, it will, for their view of the aggregation will be just that section.
Mm-hmm. And have you tried aggregations with data flows?
I have not.
Okay, it looks like at the moment that's all the questions we have. We've got a few more minutes, so if anybody wants to ask a question, I think it's a good time. If not, I think we'll be wrapping up. There are a few slides I need to say, so maybe that's a good time to go there. Okay, so thank you very much. Stay tuned for our next session, the new machine learning lifecycle, deploying and managing machine learning models at scale with Diego Oppenheimer and Cormac Foster. Thank you for
everyone.
attending.
Yes, thank you, everyone. Thank you, Michal. If anyone wants to get in touch with me, you can use my Twitter handle or you can email me directly. Thank you so much. Hope you enjoy the rest of today.
Thank you, Shabnam. Have a good day. Bye.
Thanks. Bye.